friends, welcome to lecture number 4 of EMT electromagnetic theory for BSc and MSc students. And today our topic of discussion is scalar potential and vector potential. So we're going to discuss about these two topics. Okay, I have already made 3 lectures on it. So links are given in the description box. And if you want to follow me on Insta, this is my Insta ID, let me tell you. So this is my Insta ID, Lakhyajit 123. Okay, you can follow me on Insta. Okay, if you want me to create any contents on any topic of physics, then you can suggest me. Okay, so now let's get back to the topic. And before we start, please subscribe the channel, also hit the bell icon so that you get notified when new video will be uploaded. And please support me and help me to grow my channel. Share with your friends. Okay, hit the thumbs up button as well. So now let's start. So first we're going to discuss about scalar potential. Now you see, for a conservative field, so for conservative field, electric field, so what do you mean by conservative electric field? That means suppose if we have we have electric field here, and if the work done to move a charge, this charge along a closed path is zero. If the work done along a closed path to move this charge is zero, then this electric field is said to be conservative. So hope you know these things. Now you see, for conservative field, del cross E, that means curl of this E is equal to 0. Okay, so now you see how to obtain the potential, scalar potential. Now we know that the curl, this is nothing but curl. Del cross means curl. You hope you know these things. If you if you are weak in vectors, then please go to the playlist and watch my videos made on vectors. Okay, so curl of gradient of a scalar quantity is equal to 0. So as we have 0 here, so that's why this can be expressed in terms of we can express this curl of gradient of some scalar. So let that scalar be v. Okay, is equal to 0. So then we can say that this then we can write this E is negative potential, gradient of this scalar quantity, right? And this is called, here V is called electric scalar potential. Electric scalar potential, right? This V is called electric scalar potential. And you may think, why this negative sign? If you compare these two equations, then E should be equal to gradient of V only, because this is because of direction actually. So the electric field point out in the direction in which potential energy function decreases. Okay, the direction of electric field is such that in which the electric potential energy decreases. Okay, so that's why this negative sign comes here. So hope you have understood this, why it is a negative sign. So now, so here this V is called scalar potential. Similarly, for magnetic field, now you see, here you can see that similarly for magnetic field, B, so B is nothing but magnetic field. This is B. So for J is equal to 0, if current density is 0, is equal to 0. J means current density. current density is equal to 0. In that case, we can write that in magnetostatics, we can say that curl of B is equal to 0, right? Curl of B equal to 0. So similarly, as we have done in case of electric field, we can express this one as well as a curl of grade of some scalar, right? Let that scalar be phi, then it can be equal to 0. In that case, we can write, comparing these two, we can write B vector is equal to negative gradient of phi. So here phi is magnetic scalar potential, is magnetic scalar potential, right? So now let us discuss about vector potential. Okay, so from Maxwell's equation we have got that if you have if you have studied the Maxwell equations, differential forms, then you have got this, right? This is equal to 0, right? Here B is magnetic field, divergence of magnetic field, that's going to be equal to 0, right? If that is the case, now you can see as divergence, divergence of curl of a vector is equal to 0. That's why we can express this as divergence of curl of some vector quantity. Let's suppose A, vector A. So that's going to be equal to 0. And if you compare these two, this one and this one, so this can be written in this way, that curl of A, right? So we can write that way. In that case, this A vector is called vector potential, or we can say magnetic vector potential. Right. So hope this thing is clear to you, what is scalar potential and vector potential, right? So thank you for watching. Stay connected. See you in the next video.